morning to my friends and also my fellow lecturers. My name is Kugaran, son of Segan. Together with me, I have three of my friends, which is Muhammad Hakim, Isharak, and also Muhammad Abid. The topic which has been given to us is RC step response and also RLC free circuit series.
Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone. So what's up guys, my name is Muhammad Hakim bin Khairul Saleh. My number matric is B0818100083 from course Bachelor of Electrical Engineering Industry S1/1. So this is the first main topic, which is first order step response RC circuit. There are two types of circuits, which is series and parallel. So what does the meaning of step response RC circuit? The meaning of step response RC circuit is its behavior when excitation is the step function, which may be voltage or a current source. So this is the, as you can see the series circuit and a parallel circuit. So they are resistor, you can see the capacitor and voltage source and switch. Okay, let's proceed to the next video. So this is the example of the step response of RC circuit. So you can see there's a resistor and capacitor in the circuit. So this is the formula that you will have to solve. So the formula is Vt equals to V infinity plus V0 minus V infinity exponential negative time over tau. So as you can see, the Vt is the voltage across capacitor. So first you have to find the V infinity. The V infinity is a final voltage across capacitor when times equals to infinity. Then the next step is initial voltage, V0. So the initial voltage across capacitor when times equals to 0. So the last one is you have to find the time constant, where tau equals to resistor times capacitor. So you can see the steps of the step response of RC circuit. There are 3 steps only. Okay, done. So the next circuit is second order, which is free source RLC circuit. So what is the meaning of free source of RLC circuit? The meaning of the circuit is the circuit is excited by the energy initially stored in the capacitor and inductor. It is also called as a natural response of the circuit. As you can see in the circuit, there are 3 components only, which is resistor, inductor and capacitor. For this circuit, it do not have an external source of excitation, and the other one, it contains resistor, capacitor and inductor. So let's proceed to the next video. So these are the steps or solution of free source RLC circuit that you can solve. So the first one is you have to find the V0 first. V0 equals to 1 divided by capacitor. IT dt equals to v naught. So this is the first step, and the second step is you have to apply Kirchhoff voltage law. So there are two formula that you have to apply on these steps. And next, you have to differentiate for 2 times. Is it called it's also called second order differential equation. So this is the equation of the formula. So this is the next steps that you have to solve. There are 2 formulas in this solving. So the first one is you have to find the S1 and S2. So the formula is this one. You can choose either this one or this one. So the next steps is you have to find the alpha and omega naught. So the formula for alpha is alpha equals to R divided by 2L. So the next one is omega naught equals to 1 divided LC. So next one. So the last step is that you can identify the types of natural response of free source series RLC circuit. There are 3 formulas that you can solve to find what types of natural response. So if you get the answer which is alpha is greater than omega naught, you have to use this equation. So if omega equals to same with alpha, you have to use this equation. So the last one, if the alpha is less than omega naught, then you have to use this formula. There are 3 conditions that you can find in the circuit. So thank you.
Okay, Assalamualaikum. I'm Muhammad Abid bin Mustamin. Number metric D0818100094. I will explain how about step response RC circuit. Okay, let's see example question for step response RC circuit. Okay, this is example for circuit for step response RC circuit, which is the circuit have 2 voltage source, left and right, and circuit have capacitor, resistor and switch. Okay, when t less than 0, the switch will become like this. So when capacitor connect to supply, the condition capacitor will be open circuit like this. So we have to find how many voltage output this point. Okay, solution is we apply VDR, voltage divider rule, is 5K over 3K plus 5K equal 24 voltage. The answer is 5V. So the V out is 15 volt. Okay, next we must find value of tau. So value of R equivalent is 4K from the circuit, and capacitor is 0.5 millifarad. So tau equal R equivalent times C. 4K ohm times 0.5 millifarad equal is 2 seconds. Okay, when we done to find the all value V or V infinity and tau, so the solution, the next solution is insert the all value to the formula step response RC circuit. Okay, the formula step response RC circuit is V T equal V infinity plus V O minus V infinity bracket exponent negative T over tau. Okay, insert the value in formula. So V infinity 30 volt plus VO T infinity 30 exponent negative T over 2 second. So solve the value use calculator.
My name is Isha Habib Muhammad Jamal Abdul Nasir. Today I want to explain about RLC free source circuit. Okay, this is an example of the question of RLC free source circuit. Okay, we can see it have resistance, capacitance and inductance and switch. This switch will become down when T more than 0 or equal to 0. Okay, first step, after we to find the answer, we must draw the circuit when T more than 0. When T more than 0, it become like this. It has inductance, capacitance and resistance, and inductance. It become like this. The value is and 0.4 farad. This is 10 ohm. Okay, next we find value of alpha and omega and define what state. Okay, to find alpha, we use this formula. Okay, and substitute the value and use the calculator to find the value, and we got 2 value of alpha. And omega, we use this formula 1 over third LC and substitute the value 0.4 times 2.5 and we got 1. So in this state we can determine the state is overdamped. Okay, next we write the formula relate on the question based on the state. So we use this formula because we know the overdamp. S1 T plus A2 E S2 T. How we know this state is overdamped? Because the value of alpha is greater than omega. This is overdamped. Okay, next we must find the value of S using this formula. S1 negative alpha plus third alpha square minus omega square. For S2 we use same formula, but we change the sign. This sign. Okay, so we can find the formula for S1. S1 negative 2 plus square minus 1 square, we can get negative 0. Next we must find VO and IO based on circuit T less than 0, which is it become like this. This is resistance. The capacitance will be open circuit and inductance will be short circuit. So this is IT, this is VT. Okay, we know IT become 0 ampere because the circuit does not complete. Circuit does not complete. So the current will become a 0. So we can find the VT or voltage on capacitor using the Ohm's law. V equals to IR. So we know the value of current. This is 15 ampere. 15 ampere. And the nilai and the value of resistance is 5 ohm. 5 ohm. So the VT or V on capacitance when T. Okay, next step, we compare the value we get from T less than 0 with equation state. Equation state is this. A2 exponent S2T. Okay, so we sub the value in this equation. So the value of IT is 0, we get before this, and A1 we must find it. Exponent S1 we get before this 0.2679 T plus A2 we got it. Exponent negative 3 S2 negative 3.732 T. After that, we want to find A1 and A2. We sub the value of T to 0. So we got A1 equals to negative A2. Next, we must know the equation, the other equation or equation differentiate. This negative 1 over L or value of inductance bracket R resistance I naught plus V naught. Okay. And that we sub the value to find the current, the value of current using this formula of differentiate. So then we know before this we get 0 ampere, and we get 75 volt. So the value of differentiate I, we got negative 30 ampere. So we must differentiate the equation state, so it become like this, and we must compare equation state and equation difference state. So we know the value of current in equation differentiate is negative 30 ampere, and we differentiate the equation state. So we differentiate, we sub the value before this. We know A1 equals to negative A2, so negative A2 exponent 790 plus negative bracket negative 3.732 itu exponent 3.732 T. So we must compare these two equation. This we get from equation differentiate. The value of equation differentiate. This is formula equation state. Then we differentiate. So we must differentiate the equation state, so it become like this, and we must compare equation state and equation difference state. So we know the value of current in equation differentiate is negative 30 ampere, and we differentiate the equation state. So we differentiate, we sub the value before this. We know A1 equals to negative A2, so negative A2 exponent 790 plus negative bracket negative 3.732 itu exponent 3.732 T. So we must compare these two equation. This we get from equation differentiate. The value of equation differentiate. This is formula equation state. Then we differentiate. We find the value of A2. So we can solve the equation. Negative 3.999 A2, and A2 we got 7.5. We got 7.5. Okay. Lastly, when we got all values of the circuit A1, A2, S1, S2, we combine all the values in one equation. So in equation state. So this is value of A2, A1 exponent as S1 0. T plus 7.5 exponent negative 3.32t. So this is the answer for the RLC free source circuit. This is value of A1, this is value of A2. This is value of S1, this is value for S2. So
Okay, so the last one is that we have a conclusion for the both circuits. The conclusion that we get from this assignment for the first order step response or for RC circuit, we can describe first order steps response RC circuit, and we can do the solution for the circuit and know how to apply the formula in circuit. For second order, the source free series RLC, we can describe the circuit and apply the formula in the circuit. Thank you everyone. That's all.
Okay, that's all for RLC series circuit free source. Okay, if you cannot understand in my teaching, I'm very sorry. Okay.